So now you've learned about a whole bunch of different forms that describe a circuit. We can use standard SOP or POS forms, then you've learned how to reduce those forms using a K-map. And now we've learned about NOR and NAND forms, which allow you to use all one type of gate in your circuit. So, now that we know about all these forms, how are they all related and how can we switch between all of them? So the way I like to look at this is some forms exist in the land of the zeros and some forms exist in the land of the ones. And in order to translate between the two, we need to have our handy dandy map. It's our key to go between the different lands. So yes, you can either describe your circuit based on where the ones are or based on where the zeros are. It'll give you the same information, it's just looking at the same thing through two different views. Okay, so I'm going to go ahead and create this table. We're going to have the land of the ones and the land of the zeros. The first form we're going to look at is the minterm, or I should call this compact minterm and compact max term forms. Okay, so we didn't specifically go over these in the videos, but you did see them in the reading and the problems. So in the compact minterm form, we specify all the numbers of where our ones are. So this is going to be F is equal to, and then you use the sigma symbol, so I'll just put sigma, which is that sum signal, where the ones are. So where are our ones? They're at 0, 1, 2, 3, 12, 15, 9, and 11. Okay, so there is our compact minterm form, and we could also say plus don't care of 4. Okay, now we can look at the compact max term. This is just going to tell us where all of our zeros are. So this is going to be F equals, and now you use the product symbol, what I don't know what that one's called, product, of 5, 7, 6, 13, 14, 8, and 10. And then we can use a little dot for times, the don't care of 4. Okay, so this described where our ones are, and this describes where our zeros are. Okay, the next form we can look at is the standard SOP and the standard POS. So now this you can read directly off of the compact minterm form if you know what the minterms are. So the minterm of 0 is going to be F equals A naught, B naught, C naught, D naught. And then 1 is A naught, B naught, C naught, D. And then 2 is A naught, B naught, C, D naught. As you can see, I'm just writing out the numbers in binary where the naughts represent zeros and the ones represent a 1. And now the number 3, A naught, B naught, C, D. And you can have this go on until you list every single one of these minterms. That will give you your standard SOP form, which gets pretty long, which is why we went about figuring out how to reduce these things. So now we can write the standard POS form directly from the compact max term form just by reading off where the max terms are and writing down the max terms in extended form. Just remember that the max term of 5 is the De Morgan's of the minterm of 5. So if you would think the number 5 is going to be 0, 1, 0, 1, so you'd think that would be A naught B, C naught D, but because we'd have to take De Morgan's to get the max term, we get the reverse knots of that. So what do I exactly mean by that? Well, so in standard POS form we have F is equal to the max term of 5, which is going to be A or B naught or C or D naught. So as I said, remember the number 5 you'd think of would be 0, 1, 0, 1, but because we took De Morgan's, where the ones are have the naught symbol now. So there's our max term of 5. We're going to AND that with the max term of 7, which is going to be A or B naught or of 6, C naught or D. I'm going to AND that with a max term of 7, which is going to be A or B naught or C naught or D naught. And we would do the same for 13, 14, 8, and 10. And there we go. That would give us our standard POS form. Okay, so now to get the reduced forms of the equation, guess what you have to do? Well, you go to the K-map and you reduce the equation using the techniques we have learned. So let's do the reduced POS, which is going to be circling the ones. So we can make our biggest grouping of ones right here. And then we got another grouping of 4 right here. Then we still have to cover this one, so we're going to put that in this group of 2. And then we can put this one in this group of 2 with the don't care. Okay, so we're going to have 4 terms. This first term looks like it's going to be an A naught, B naught. Then this group of 4 is going to be a B, D. And then we've got these 2 groups of 2. I've gone ahead and written those down already. So there we have our form here in reduced SOP. We have F equals A naught, B naught, which was that first one, A naught, B naught, and then we had the, this was our A naught, B naught, and then we have our B naught, D, and there it goes, or A, C, D, or B, C naught, D naught. Great. Okay, so that's how we get our reduced SOP. Now what if we wanted our reduced POS? Well, guess what? Since we're now in the land of the zeros, we're going to circle the zeros. So we're going to have this guy, with this 0. My pen doesn't seem to want to work. And then we're going to have these 2 zeros. And these 2 zeros, and these 2 zeros. Okay, now remember, when you're doing a POS form, you're going to be writing the equation for F naught first in SOP and then taking De Morgan's. Okay, so F naught is going to be A, B naught, D naught. Or let's look at this grouping of zeros. This one's going to be a B, C, D naught. And then we're going to have a naught, B, D. And then this one is going to be a B, D, C naught. B, C naught, D. Okay, so then in order to get it in POS, we take De Morgan's. So we're going to get F equals A naught or B or D, ANDed with the rest. And I've gone ahead and written that down already, so you can see that we have just converted the whole SOP form for F naught into POS for F, which is what I have as the reduced POS. Okay, so the last form is pretty easy. We want to go to NAND, NAND, and NOR, NOR. NAND, NAND is again in the land of the ones. NOR, NOR is in the land of the zeros. We can easily go to NAND, NAND by taking the reduced SOP and complementing it twice. So you put the double bars over each of these. That's going to change all of the additions here to multiplications, and it's going to knot each of the individual terms and then knot the whole thing. So you can see all we did was we copied down the same equation, we knotted each term individually, which is why they're in parentheses with this knot. We changed the ors to ands and we complemented the whole thing. Similarly with POS, we can start with the reduced POS form to get to NOR, NOR. In the land of the zeros, we take the reduced POS form, we change the ands that are in between to ors. Oops, that should be changed to ors because we're in NOR, NOR. Each of these are complemented. and the whole thing is complemented. So that gives us a whole NOR form. So now you can see how they're all related. We have the land of the ones and the land of the zeros. To get between the two lands, you want to go to your K-map. So let's say you started off, instead of starting with the K-map, let's say you were just given this form of the equation. Well, what you would want to do with the NOR form is first convert it to the reduced POS form by getting rid of the over bar and changing the ors to ands to get into your reduced POS form. And then once you have your reduced POS form, I would convert that into a reduced SOP form for F0. That means getting back into this equation. And then once you have that equation, you can know where your bubbles are and fill in the zeros. So anytime you are given any of the things in the land of the zeros, you know that you can fill in zeros into your K-map, and the equation tells you where it is you need to fill them in. So for example, we need to fill in zeros for A, B naught, D. Well, you find in the K-map where that exists, A, B naught, D naught, sorry, A, B naught, D naught. It's going to be these two zeros, so you can go ahead and fill in zeros in the K-map right there. Once you've filled in all the zeros, if you were given something in the land of the zeros, the rest of them are going to be ones, and then you could get to any other form you'd like. So that's sort of the key to how to switch between forms and the key to how they're all related.